Okay, so I'm going to be creating a voltage divider. So let's say I have a 9-volt battery and a voltage divider looks like two resistors in series. And what I want is I want to split the voltage of my battery equally. So I want to be able to measure the voltage at a point. So at this point between the resistors, I want to measure this and I want the voltage out to be 4.5 volts. So when I say I want to measure the voltage at a point, what it means is I'm not typically measuring the voltage at across a resistor. And I'll just show you what I mean. So if I said I wanted to know the voltage at this point right here, I would take my multimeter, I would connect it, the ground, the black probe to ground here, and I would do the red probe here, and I would measure the voltage with reference to ground. So here I'm going to measure 9 volts. Here, when I move, I'm going to measure 4.5 volts. And here I'm going to measure the voltage here at 0 volts. So that's voltage at a point. We're just lucky enough here that the voltage across this resistor is the same as the voltage measured at that point because the bottom of the resistor is connected to 0. So that voltage drop is the same as the voltage at the point. So if I want to split this, I know that if I make the resistors the same, so if my R1 and R2 are equal, then I will split the voltage equally. So what else do I need to decide? How do I pick my resistor? Well, you can pick what you want, but you need to make sure usually that the current is low. So if I were going to do this, I might pick a resistor value of 1,000. R1 is equal to R2 is equal to 1,000 ohms. And so I can calculate, so for a voltage divider, if I wanted to find the voltage across 2, I can use a ratio of R2, the resistance of R2, over the resistance of the total, so R1 plus R2. Right, and I can then multiply that by, so that gives me the ratio. So in our case, it's going to be R2 is 1,000 divided by R1 plus R2 is 1,000 plus 1,000. So it's going to be 1,000 over 2,000, which is a half. So a half of the voltage times the voltage is going to give me 9 volts, right? So if I plug that in, I can say 1,000 divided by 2,000 times 9, right? That's a half of 9, and that's going to give me 4.5 volts. Pretty easy, but let's check the current. So I usually want a pretty low current, and so when I use 1,000 ohm resistors, I'm going to be in the milliamp region. So that's pretty good. So let's see what I get. So I is equal to E over R total. So I'm going to have 9 volts over 2,000 ohms, right? Because I'm doing the equivalent resistance. I'm adding them together, and I'm going to get 0.0045 amps, which is the same as 4.5 milliamps. Okay, so we know that now we've got a low reading for current, so that's good. And what we can do is if we decided we needed a different current level, then we could find the current level. So find this value for the equivalent resistance that gives us the current, and then take that number and split it in half, and then we can find resistors that are very close to that number, which should give us the current that we want.